Hello friends, I am Chetan Ingale, working as an assistant professor in the Department of Chemistry of Rayat Shikshan Sanstha's RBNB College, Shrirampur. Up till now, we have studied or we have came across the reactions of alkyl halides. In our previous lecture, we have talked about what is meant by elimination reaction. In this particular lecture, that is in today's lecture, we have to study what is meant by substitution reaction and its types. Now, we know that what is meant by substitution reaction. Substitution reaction is nothing but those reaction in which one of the atom or group of atom is substituted from an substrate by the another incoming atom or group of atoms. Now we know that what is meant by substitution reaction. In this case, those reactions in which an atom or group of atoms from what? From a substrate that substrate is also called as reactant. That substrate is also called as reactants, or sometimes it is also called as starting material of the reaction. We have to replace an atom or group of atom from substrate by the incoming atom or group of atoms is nothing but substitution reaction. Depending upon the substrate used, that is, if we use aliphatic or sometimes we may use aromatic substrate, and the incoming or the group which is used for replacement, on that basis, whether it may be nucleophilic in nature or it may be electrophilic in nature, this substitution reaction is classified as follows. Depending upon what? Depending upon the substrate and the incoming atom or group of atoms, this substitution reaction is classified into three types. The first one is aliphatic, nucleophilic, substitution reaction. The second type of this substitution reaction is nothing but aliphatic electrophilic substitution reaction. And the third one is nothing but aromatic electrophilic substitution reaction. Due to the nucleophilic nature of aromatic ring, these aromatic compounds cannot show aromatic nucleophilic substitution reaction, because we know that each and every aromatic ring has a pi electron cloud. Due to their pi electron cloud, this aromatic ring becomes nucleophilic in nature. That's why the attack of nucleophile on somewhat nucleophilic aromatic ring cannot be possible. That's why aromatic nucleophilic substitution reaction cannot be shown by these aromatic compounds. Now, one by one, we have to go through the types of substitution reaction. The first type of substitution reaction is nothing but aliphatic nucleophilic substitution reaction. In this type of substitution reaction, one of the weaker nucleophile from substrate is replaced by the another stronger nucleophile from the reagent. Those reactions in which weak nucleophile from what? From substrate is replaced by what? Is replaced or substituted by what? By strong nucleophile. The hybridization of carbon atom on which the weak nucleophile is present, and after the completion of reaction, that is when the product is formed, and in this product, if we study the hybridization or if we determine the hybridization of carbon atom on which strong nucleophile is present, is unchanged. It means the carbon atom from which we have to replace the nucleophile, the hybridization of that carbon atom and the carbon atom on which we have to apply or we have to add the nucleophile, that carbon atom's hybridization is unchanged. Means for that purpose we have to see an example of aliphatic nucleophilic substitution reaction. Alkaline hydrolysis of methyl bromide. When we carried out an alkaline hydrolysis, it means action of aqueous NaOH on what? On methyl bromide. when this methyl bromide is treated with alkali mixture, that is aqueous NaOH or KOH, this aqueous OH negative, which acts as a stronger nucleophile than this bromine. Now we know that the definition of aliphatic nucleophilic substitution reaction, which says that the stronger nucleophile will replace the weaker nucleophile. It means when this strong nucleophile will attack on this carbon atom, then this bromine, which is weak nucleophile, will be substituted by this OH negative to form alcohol, that is methyl alcohol, as a product with the removal of KBr or NABr. I show Br negative because here also we cannot use a counter ion part. If I use here Na positive, that is NaOH, then here we will obtain NaBr, that is Na positive Br negative. When we look at this carbon atom, we know that the hybridization of this carbon atom is sp3, and we also see towards this carbon atom, we understand that this carbon atom also has sp3 hybridization, and we have seen that in case of aliphatic nucleophilic substitution reaction, there is no change in the hybridization of carbon atom on which a replacement of nucleophile takes place. Now we have to move towards our second type of this nucleophilic, this substitution reaction. Now the second type of substitution reaction is nothing but aliphatic electrophilic substitution reaction. This aliphatic electrophilic substitution reaction is denoted by capital S suffix E. Now, in this particular electrophilic substitution reaction, one of the atom or sometimes hydrogen atom from saturated carbon is replaced by the electrophilic part of the reagent. In this case, one of the hydrogen atom from what? From saturated carbon, that is alkanes, is replaced by the electrophilic part of the reagent. In this case also, or in this aliphatic electrophilic substitution reaction, also the hybridization of carbon atom on which the replacement of atoms or group of atoms takes place, that hybridization cannot be changed. For that purpose, we have to see an example of this aliphatic electrophilic substitution reaction. Now, we know that when ethane molecule is treated with concentrated nitric acid at 400 degrees Celsius, we will obtain nitroethane as a product. That is, we will obtain nitroethane as a product. We have seen that this concentrated HNO3 produces a nitronium ion which is used as an electrophilic part of the reagent, that is electrophilic part of this HNO3. That is, we use this nitronium ion. This is nitronium ion which is used as a electrophilic species of this concentrated HNO3. Now this electrophilic species replaces one of the hydrogen atom from this ethane molecule to form what? Nitroethane as a product. When we deals with the hybridization of this carbon atom from the reactant and the hybridization of this carbon atom from which we have replaced what? We have replaced hydrogen atom from by NO2. We will obtain that this carbon atom and this carbon atom, both this carbon atom has the same hybridization. Okay, now on that basis, in this case also, the hybridization of carbon atom does not change. Now, the third type of substitution reaction is nothing but aromatic electrophilic substitution reaction. In this particular substitution reaction, one of the atom or group of atom from aromatic moiety is replaced by the electrophilic part from the reagent. Now, in this case, one of the atom generally that atom would be hydrogen atom which is present on the aromatic ring, that is hydrogen atom is substituted by the electrophile or electrophilic species or electrophilic part of a reagent. This aromatic electrophilic substitution reaction is also abbreviated as AR-SE. AR for aromatic, S for substitution, and E stands for electrophilic. Okay. Now, like our aliphatic nucleophilic substitution reaction and aliphatic electrophilic substitution reaction, in this reaction also there is no change in the hybridization of carbon atom. Now, to understand what is meant by aromatic electrophilic substitution reaction, we have to study the reaction of, or we have to know, or we have to draw the reaction of this particular type of reaction. Now, when this benzene molecule is treated with nitrating mixture, that is concentrated HNO3 and H2SO4, we know that the mixture of concentrated HNO3 and concentrated H2SO4 liberates or produce an electrophile, that is nitronium ion. We have already taken, or we have already studied what is meant by nitronium ion and how will the nitronium ion will be from this nitrating mixture. That's why we know that in this case, when this benzene is treated with what? Nitrating mixture, one of the hydrogen atom from this benzene ring is replaced by the nitronium ion, and we will obtain this nitrobenzene as a product. This is all about the aromatic electrophilic substitution reaction. In this reaction, the carbon atom from which we have replaced this hydrogen atom, the hybridization of this carbon atom and the hybridization of this carbon atom on which nitro group is present is same, that is it is sp2. It is sp2. Now, this is all about the substitution reaction and its type. In this S.Y.B.Sc syllabus, aliphatic nucleophilic substitution reaction is included, which is we have to solve or we have to study this aliphatic nucleophilic substitution reaction. Now, one by one, we have to take what is meant by or the types of nucleophilic substitution reaction. We have already studied that aliphatic nucleophilic substitution reaction is nothing but the replacement of weak nucleophile from the strong nucleophile. We know that this aliphatic nucleophilic substitution reaction are further classified into three types, that is SN1 reaction, that is unimolecular nucleophilic substitution reaction, SN2, that is bimolecular nucleophilic substitution reaction, and SNI reaction. Now, the detailed study of these reactions, are included in our syllabus, and we have to take that SN1, SN2 and SNI reaction in our next lecture. Thank you.